Right, so Bismillah ar-Rahman ar-Rahim. In the last class, we talked about, first of all, distance vector routing. Then we talked about hierarchical routing and described how routing is done in the internet. Then we talked about the protocols that are used in the internet, namely RIP, the Routing Information Protocol, as well as OSPF, which is a protocol based upon the link state algorithm. And then we started talking about BGP, as well as how routing is done across autonomous systems and allows us to scale to the entire globe. So any questions before we start? So in today's lecture, we'll be covering BGP, and then if time permitting, we'll move on to the data link layer. So just to recap very quickly, hierarchical routing is the way to go in the internet, because routers actually function within autonomous systems. You have some ISP, you have some entity which controls all the routers within a certain region. Now, within that autonomous system, of course, you will use routing algorithms such as RIP or OSPF, and you will basically want to minimize or optimize the routes that you take within that autonomous system based upon metrics such as hop count or the capacity, bandwidth, or the congestion. So routers in the same autonomous system run the same routing protocol, and that is called an intra-autonomous system routing protocol, an IGP. Routers in different autonomous systems, of course, can run different intra-AS routing protocols, and then these autonomous systems are glued together at the edges through routers known as the gateway or the border routers. So here's an example. We've got these three autonomous systems, and you've got the border routers over here which connect these autonomous systems. Now, the forwarding table configured both is configured by both of the intra and inter-routing algorithms. So if you have some router which is interior within an autonomous system, then it needs to know how to get to routers within the autonomous system, as well as to get to destinations outside its own autonomous system. And for that, it has to somehow get that information that कौन routes जो हैं, they are outside my autonomous system, and then to get to there, how should I get there in terms of what is the next hop decision that needs to be taken at a particular router. So वो करने के लिए you have to have these intra-autonomous system routing algorithms as well as the inter-autonomous system routing algorithms. They will come into interplay to actually create the forwarding tables. So the intra-autonomous system sets for internal destinations, whereas the intra-autonomous systems, intra-autonomous system routing algorithms, along with the inter, are going to set the internal entries. Now, why do I say along with the inter? That is because the intra ones are the protocols which are going to work between autonomous systems, but then that information has to be propagated internally within the autonomous system, number one. And number two, then when that's propagated internally, the decision inside here is, okay, how to get to a border router so that you can move towards the autonomous system, जिसके ज़रिए से then you will get to the ultimate destination. Okay? So the inter and intra both interplay to create the forwarding tables so that you can get to both internal as well as external destinations. Any questions here? जी, any questions? इसमें कोई चीज समझ आई? Okay. Can you all hear me?
Yes.
Okay. The task can. Okay. So the tasks of the inter-autonomous system routing protocols is very interesting, because suppose a router in AS1 receives a datagram which is destined for some outside destination. So to get to the outside destination, you've got to go through the border gateway router. But the question then becomes is that which particular border gateway router do you need to get to? So, for example, here you've got two border gateway router protocols which connect AS1 to AS2 and AS3. AS1 is connected to AS2 via 1B. It's connected to AS3 via 1C. Okay? So you need to learn which destinations are reachable. That's the word we use. So you need to work the reachability of a destination, whether that destination is reachable through AS2 or it's reachable through AS3. If it's reachable through AS2, then you've got to forward your packet through 1B towards the border gateway router there, which is 2A. If it's reachable through AS3, then you'll have to forward it through your border gateway router 1C towards the IP जो केस इंटरफेस के ऊपर है 3A राउटर को जो कनेक्ट कर रहा है वहां तक आपने उस पैकेट को पहुंचाना है and that is what you would want to do. So then propagate this reachability information. Okay, ultimate IP जो range of addresses हैं जो वो किस particular AS के through route होंगे, and then that information needs to get to each one of these internal routers over here ताकि जब उनके पास एक packet आता of that destination, so they know that they need to forward that packet towards that AS through that border gateway router to that IP next hop IP जो वहां तक पहुंचना है उसके लिए यहाँ पे at their router what should be the next hop decision that they need to take. So we took the example, you need to get to destination X, okay, which is some sub route, okay, some sub network, okay, and for example that's connected to AS3 only, and you're sitting over here in AS1 at router 1D. So if your destination is the sub network X, then 1D needs to somehow forward this packet to the border gateway router 1C, and that forwarded to AS3 ताकि आप X तक पहुंच सके. Okay. So if L is the next hop path from 1D to 1C, then to get to X, you need to have a forwarding entry in the table. कि अगर आपको X को जाना है, तो यहाँ पे the decision is that you need to get to the next hop has to be L that takes you there. Similarly, if X is reachable through both AS3 as well as AS2, then you've got potentially two paths. आप 1B के through AS2 के through X तक पहुंच सकते हैं, or you can get from 1C through AS3 to X. And then the decision is going to be कि okay, कौन सा path लेना है आपने, ठीक है? And to decide that, basically the decision is कि जी आपको कौन सा border router करीब पड़ता है. That could be one of the things. It could be based upon other metrics. But that decision is basically कि आपने इस AS के अंदर इन border routers तक कहाँ कैसे पहुंचना है, ठीक है? And that is going to be basically a decision based upon your intra AS protocol जो इस AS के अंदर चल रहा है, ठीक है? So you learn from the inter-autonomous system protocol that a particular subnet is reachable via multiple gateways. You use routing information from the intra-AS protocol, जो उसी AS के अंदर चल रहा है. You determine the least cost paths to each of the gateways, and then you decide, okay, which path you're going to take. It could be hot potato routing, which is choose the gateway that has the smallest least cost, and then determine the forwarding table entry or interface that leads to that least cost gateway, और वो आपने enter कर दी अपने forwarding table के अंदर. So you have an interplay of both the inter-autonomous system routing protocols such as BGP, as well as the intra-autonomous system routing protocols such as OSPF or RIP, RIP, जिसके जरिए से ये entry ultimately build होगी आपके forwarding table के अंदर. Okay, so any questions before we move to BGP? Any questions? G. Question here in the chat. Yes, that is probably the previous question. But any questions? Okay, so the internet routing is done by BGP. That is the protocol. This is the protocol which allows us to globally route packets all over the internet, every single country, every single region, every single destination. So it's the de facto inter-domain routing protocol. It's the glue, it's the duct tape, whatever you want to call it, that holds the internet together. अब BGP में आपके पास you've got to get to autonomous systems, उसके लिए दो protocols और sub protocols आप कह लें. एक exterior BGP है which obtains the subnet reachability information from the neighboring autonomous systems, or then IBGP or interior BGP hai, which propagates that reachability information to all ASs within the AS, within the internal routers of NAS. Okay. So you need to determine good routes to other networks based on reachability information as well as policy. Okay. So if I were to say BGP is entirely policy driven, that is very true, because reachability information कि आप किस destination तक पहुंचने के लिए क्या route लेंगे, क्या path लेंगे, that reachability information आपके पास आ जाएगी सारी, and then you have got multiple paths that you might want to take, and then it's a matter of policy, that which path you're going to take, because you're not necessarily optimizing a cost function to the ultimate destination. वो आप कर भी नहीं सकते, and there are reasons for that, and there are good reasons for that. Within your autonomous system, you can do any optimization of cost, distance, and because you have full control over things. But when you actually forward your packet to the next autonomous system, then you have no control over anything. उस autonomous system में 2 routers हैं, 50 routers हैं, 100 routers हैं. You don't even know कि कितने routers हैं in that next autonomous system. ठीक है? And what path is going to be taken there, you have no control over that. Okay. So this path is the route that you take to your destination. वो simply you simply find out कि okay किन autonomous systems के through traverse करके आप ultimate destination तक पहुंच सकते हैं, and then you have the policy decision based upon your peering relation, your connectivity relations with these other autonomous systems. So each autonomous system will have a peering relationship, a connectivity with other autonomous systems. So let's say one of them is controlled by PTCL, another one of them is controlled by, let us say, Mobilink, a third one is controlled by some other network operator, let's say Ufone. Then you've got other network operators which take this traffic outside the country. It could be Singapore Telecom, Singtel, or you could have other operators जो कि आपकी traffic को बाहर लेके carry करके जा रहे हैं, ठीक है, which then ultimately connect you to other big operators such as AT&T or Sprint and so on. So then you will have agreements with each one of these ASs which are directly connected to you, and you will have to pay them अगर आप उनसे bandwidth ले रहे हैं, ठीक है, and based upon those sort of contracts that you have, and based upon how much you actually get to pay, वो जो policies हैं, उसकी basis के ऊपर ये सारे decisions by and large किए जाएंगे. And basically what BGP does is that it allows the subnet to advertise its existence to the rest of the internet, I am here. Now, that information that some network is here, usko aap necessarily propagate nahi karenge to everybody. That is not true. You will filter that information and you will only propagate reachability information based upon your peering relations, based upon the contracts that you have. Okay? And we'll come to this in a minute, because on the one side, this traffic which is going through the entire globe, okay, it's being carried by autonomous systems based upon these trust relationships that you have with other autonomous systems. Okay? So you might have some other autonomous systems that you might not trust or might not want to route your traffic through. Okay? And therefore, your policy decisions are going to be based on these relationships or policies rather than on optimizing the distance metrics or anything else. What is the shortest path in terms of end-to-end propagation delays and so on. The way it works is that you have a BGP session, BGP routers, which are interconnected. Interconnected routers are called peers. They exchange BGP messages, and those messages advertise paths to different destination network prefixes. So remember, network prefix kya cheez hai? That's your IP address along with a slash and a number between 1 and 32. जो ये बताता है, it's an aggregate range of addresses जो कि आप reach कर सकते हैं. You can get to a certain set of destinations. So these are your network prefixes, and those network prefixes along with a path meaning AS2 through, and then AS5 through, and then AS7 through. That so notice here the path is not in terms of explicit routers. The path is in terms of entire autonomous systems or groups of networks. Okay? And वो जो path है along with the destination prefix, that together makes what you call a route. So these paths to different destinations of network prefixes, or in other words, these routes are exchanged over semi-permanent TCP connections. So these routers have TCP connections. जिसके ज़रिए से they are going to exchange these BGP messages so that information कि आप किन destinations को पहुंच सकते हैं, that reachability information is actually exchanged. So for example, AS3 advertises to AS1 that you can get to so many destinations through me. So it promises that it will forward datagrams towards those prefixes. Okay? So AS3 can aggregate prefixes in its advertisement. So it can say, "Acha, ye sare bhi, and ye bhi," if it can do some aggregation on those prefixes, it would aggregate all of those prefixes in the advertisement. You can get to all of these networks through me. So not only its internal addresses, but also addresses of other networks that it is connected to, and it can route packets to those networks. Unko ye yahan pe, it's going to advertise that information over here. Okay? Now notice that it could be connected to other networks, but it may not necessarily announce that information, and that will come to in a minute. Okay, ye filter karta hai. It doesn't necessarily announce all routes when it sends out this BGP message. Okay. So using external BGP, ठीक है, आप एक section चला रहे हैं, for example, between 3A and 1C. So AS3 sends a prefix reachability information to AS1. So 1C can then use that information. Okay, I can get to these destinations. It sends out that reachability information to all of the interior routers within AS1 through internal BGP, or sorry, interior BGP, IBGP. See? Okay. Now, when that information gets to this border route over here, which is 1B, then 1B can then re-advertise this new reachability information, okay, which includes those destinations जो AS3 के through reachable है, उनको भी ये forward कर देगा through an external BGP session to this router over here, which is 2A. Okay. So notice that the border routers have these external BGP sessions to other border routers. Okay. And within the autonomous system, the internal BGP sessions distribute that information to internal routers. And while that is taking place, आपके पास दूसरे जो border routers हैं आपके, उनकी जो reachability information है वो भी आ जाती है, which you then use to collate and come up with a message using like exterior BGP to this other border gateway router that you can get to these other ASs through me. So for example, ये जो AS3 की information है, you can get to AS3 through AS1 that is received over here at 1B, and then through exterior BGP that is then passed on to 2A. Okay, let's see. Okay, so why is it semi-permanent? Okay, so Zatash will explain that. Okay. So TCP, as you know, is a connection-oriented protocol. When you have a connection which has been established, then you don't need to re-establish that connection. So जब new routes आपके पास आते हैं, so then it's efficient to simply announce those over existing connections, and that's why we say that they are semi-permanent. The question is that why aren't they permanent? Well, of course, routers can go down, and they can go down for a number of reasons. Maintenance के लिए भी down हो सकते हैं, other reasons के लिए भी down हो सकते हैं. So therefore, we call this semi-permanent as opposed to permanent. Right. So any questions over here? किस तरह से आपने AS3 की reachability information 1C तक पहुंचाई through an external BGP session that is then propagated internally to all interior routers of this AS, including this border router over here, which is 1B. So 1B then knows that it can get to AS3 and all these other networks beyond AS3 through this particular border router over here. And it then propagates that information that, well, you can get to AS1 as well as to AS3 and all these other networks beyond through this border gateway router over here, और ये सारी information 2A को मिलती है, which then internally disseminates that information through IBGP or interior BGP sessions throughout its own AS and so on. And that's how this reachability information is sort of percolated through the entire internet. And obviously, you'll get multiple routes to a particular destination, and then based upon a certain policy decision, you will actually figure out that, okay, what is the actual path that you need to take to a destination? What is the best path? And then based upon that, you will decide, okay, मुझे next hop पे क्या forwarding decision करना है, and that is how the entry in your forwarding table is created. So a route includes a prefix, which is the range of IP addresses, ठीक है, and an attribute. And attribute के अंदर आपके पास you have two important attributes and we'll come to this in a minute. लेकिन attribute ये prefix और attribute मिला के आपके पास एक route बनता है. Now an AS path contains the names of the ASs which you will traverse to get to a destination. For example, AS67, AS117, and so on. AS के numbers होते हैं, ठीक है? And then you have the next hop, which indicates the IP address of the specific internal AS router to the next hop AS, ठीक है? So इस router का जो address है, that is the next hop that is indicated over here. Then you've got policies which you import, okay? And it's all based upon policies. So आपके पास जो भी peering autonomous systems हैं, they will have a number of contracts between them, and they will be entirely driven by these policies. So a router may learn about more than one route to the destination autonomous system, and it will select the route based upon the local preference value attribute, some policy decision that you might have a policy decision which says that, okay, all traffic out of Pakistan is going to go through this particular gateway or these gateways. Okay? All traffic out of Pakistan goes out through Karachi. Agar usne, it has to go through a submarine cable, then it has to go out of Karachi. Okay? So that could be a policy decision, and therefore all traffic is going to get routed to Karachi. It could be based upon the shortest AS paths that you have. Okay? It could be based upon the closest next hop router, which is hot potato routing, or it could be based upon additional criteria. So shortest AS path का मतलब ये है कि if I want to get to a destination X outside Pakistan, let's say, so एक route मुझे मिल रहा है which is taking me through 2 autonomous systems. Another route is taking me through 4 autonomous systems. I might decide to take the path with the shortest AS path, which is going to be through the one which has just 2 ASs, so I'll only traverse 2 ASs. Notice when I say traverse 2 ASs, I might end up having more hops because on 2 ASs, those could be bigger ASs, and I might have to do more individual hops in each one of those. Okay? So that does not necessarily guarantee if I have a shortest AS path, I will have fewer hops to my destination. Okay? But you wouldn't know here exactly किस AS में कितने hops इस्तेमाल हो रहे हैं. But then of course, because these are peer autonomous systems, and you know कि उनके यहाँ क्या sizes हैं, कौन से routers हैं, क्या चीजें हैं. So your policy might override that at times. So basically, you get these complex lists of policies कि जी in routes के लिए आप ये path लेंगे, in routes के लिए आप ये path लेंगे, in routes के लिए आप ये path लेंगे, and so on. So the BGP message is exchanged between peers over TCP connections, and typically the messages types, some examples are open, to open a TCP connection and get authenticated, to update, to advertise a new path or withdraw old paths, keep alive so that you know the other peer BGP router is alive. In the absence of this, you know it's gone down. You will then request it उसको फिर यानी even so if you don't receive a heartbeat signal from a peer connection in a certain while, then you've got decisions like, okay, let's wait a bit, maybe it comes back up again, then before you sort of change your routing tables, because changing routing tables it takes a long time. Okay? So then उसके बाद ये है कि you might report errors in previous messages, and also you might want to close down connection. So you have some kind of a notification message that is also exchanged between BGP routers. So then putting it all together, how does an entry get into a router's forwarding table? Well, you need to tie together both hierarchical routing as well as BGP and OSPF. And this, of course, is interesting. So here's an example कि आपके पास, for example, ये forwarding table में ये entry कैसे आती है? Notice forwarding table में the entries that you have is for these prefixes, or for this prefix, I should say, or in other words, for these range of addresses, the next hop is going to be output port 3. For these range of addresses, or for this prefix, ये output port है next hop पे, and for this, it's going to be this. So that's your local forwarding table. But how is this entry in the forwarding table built? Well, it's built through routing algorithms, and these routing algorithms basically run between routers. And of course, यहाँ पे, if this prefix is not within your autonomous system, it's inside some other autonomous system, then of course, ये कैसे आएगा? Well, first of all, the router becomes aware of the prefix. It determines the output port for that prefix, and then it puts that entry in. How does it become aware of it? That is done through a BGP message which contains routes. So for example, the route is a prefix, an attribute such as the autonomous system path, autonomous system के through आप उस destination range of addresses या उस prefix तक पहुंच सकते हैं, as well as next hop क्या है to actually get there. So an example is ये जो range of addresses हमने लिखी थी वहां पे, to get to there, this is the path AS3, then beyond that AS131, then beyond that it might be, so these are the two ASs that you need to traverse to get to there. And the next hop is going to be the IP address of the router, जिस जो कि आपको is going to take you there, ठीक है? And this next hop is of course going to be an interface on your border gateway router, ठीक है? Now, if you get a BGP message from two border routers that you can get to some destination, ठीक है, to the same destination, तो ये दोनों आपके पास paths आ गए. So then you have to select one of these paths, and in order to select the path, for example, if your policy says that you will select the shortest path, तो एक route आपके पास आया है कि जी इस prefix तक पहुंचने के लिए you will take AS2, AS17. Another route that you get is that to get to the same prefix, you will take the route AS3, AS131, AS201. Your decision might be to take the shortest AS path, and that would be the first one. So you will select this particular AS path, and then corresponding to that, you would then put that entry there in your table. What happens if there's a tie, if you have two AS paths with the same number of ASs that you have to traverse? So we'll get to that back to that in a minute. So once you select the route's next hop attribute, that is the IP address that you need to get to. That IP address, of course, is going to be part of a subnet, and उस subnet तक पहुंचने के लिए you will have reachability I shouldn't say reachability. Basically, you'll have information regarding that through the intra-AS protocol that is running over here, such as OSPF or RIP. Okay. So the router uses OSPF information to find the path from the router 1C to that particular destination. Okay. And उस subnet तक पहुंचने के लिए because this IP address is going to be on some subnet, उस तक पहुंचने के लिए whatever is the next hop interface that you need to take, वो entry आपके पास आ जाएगी. For example, here it's port 4, which takes you to the next hop router interface, and that port 4 is the entry then that you will place in the forwarding table. That to get to this prefix, port 4 is the next hop that you need to take, and that's how the actual forwarding table entry is built within the forwarding table using both BGP as well as the exterior BGP as well as interior BGP protocols to actually send that information from the AS2 through 1B to 1C, as well as OSPF to actually work out, okay, उस तक जाने के लिए, उस next hop router तक जाने के लिए, what is the actual path that has to be taken, and what is the next hop router, next hop port that you have to, next hop interface or next hop port that you have to take to so that that packet is forwarded and it gets to the next hop router along the path to the ultimate destination. Suppose there are two or more routes which result in a tie, then you could choose the closest next hop router. So OSPF is used to determine which gateway is the closest to you. And for example, आप यहाँ बैठे हैं, एक hop, एक जो the route है वो आपको AS3 के through लेके जा रहा है and you're directly connected there. दूसरा जो है आपको AS2 के लिए through लेके जा रहा है and उसके लिए you have to get through 1B. So you might choose the route which is closest, which has the closest next hop, and in that case you're going to use AS3 because 1C पे अगर आप बैठे हैं, then you're directly connected to 3A, whereas to get to AS2 you'll have to go through this other gateway router, and that from 1C is more distant, and therefore you will choose AS3, and then amongst these two paths, since you will choose AS3 because that is closer. So in summary, how does the entry get there? The router becomes aware of the prefix via BGP route advertisements from other routers. You determine the router output port for the prefix, and then you use BGP route selection to find the best inter-AS route. Then you use OSPF to find the best intra-AS route leading to the best inter-AS route, and the router identifies the router port for that best route, and वो entry आप फिर forwarding table में डाल देते हैं. Now, any questions before we get to the policy thing? जी, any questions over here? कि ये entry actually build कैसे होती है? Okay, so BGP routing policy. Now, this is very, very interesting and practical. अब यहाँ पे we've got two notations. एक आपके पास customer networks के, you've got these round notations. So you've got three customer networks, X, W, and Y. And then you've got three provider networks. These are the ISPs A, B, and C. And notice कि आपके पास जो customer networks हैं, ये हमेशा आपके पास edge पे होंगे. They're going to be at the endpoints. They're going to be at the edge. So you'll have some access network which connects you from the customer network to the provider network. And then these provider networks have larger capacity links. It's shown by these thicker black lines. And we just have three provider networks over here. But the idea is to provide an example. So obviously these provider networks in reality will be connected to bigger provider networks, bigger pipes, more capacity links, and ultimately वो फिर आके नीचे connect करेंगे किसी और customer network के साथ end-to-end connectivity के लिए. But in sort of summary, you'll have some structure like this where you have an interconnection between network providers with high capacity links that make up sort of the backbone or the core. And आपके पास यहाँ पे at the edges, you've got these customer networks which have lower capacity links. Now, the provider networks are ABC, the customer networks are XWY, and X, of course, is interesting because X is dual-homed. It's attached to two provider networks, so it's attached to both B as well as to C. Now, the question is that आपके पास यहाँ पे जो X है, it would like to receive traffic from the provider network B. It would also like to receive and transmit traffic to provider network C. Same with provider network B. But X does not want to be a transit for traffic between B and C. So अगर X advertise करता है कि okay, if X advertises to C that I can get you to B, or it advertises to B that I can get you to C and beyond, then you'll have traffic which is going to be traversing this customer network. Traffic destined for somewhere else, instead of going directly between these provider networks, will be routed through X and then out of here. Now, would you want that? Would you want that? जी, क्या ख्याल है आपका? If you're a customer of B and C, would you want traffic? Maham says no. Now, why not? Why not? I mean, it's perfectly okay. It's perfectly legitimate that you can route traffic through here. Why wouldn't you want to route traffic? So why should I not enough capacity in my links? Suppose you had capacity in your links, फिर आप करेंगे? Okay, that's the right answer. You're a customer, So basically, आप जो भी traffic आपकी तरफ आ रही है या आप जो traffic डाल रहे हैं यहाँ पे in any of the networks, you're paying for that. You're a customer. Now, traffic which is destined for customer Y, if that gets routed from B to X to C, X is not getting any money for that, but X is actually paying for that, and उसको कोई फायदा नहीं है because that's not traffic for it. So just for transiting traffic as a customer, आपको पैसे पड़ रहे हैं. For somebody else's traffic, that is something that you don't want to do. So basically, all these routing policies that BGP has are based on these decisions. That you would only want to carry traffic जो आपके कस्टमर की ट्रैफिक है, बिकॉज अल्टीमेटली उस ट्रैफिक को कैरी करने से you're going to get money out of that because you're going to get paid for that, ठीक है, but you wouldn't want to carry traffic for which you're not getting paid. That's a general principle, ठीक है. For example, okay, so isn't that how P2P connections would work? वो बात सही है, but then देखें P2P में आपको कोई ना कोई फायदा हो रहा है, so you're okay doing that. So P2P में you're okay sharing because then आपको भी फायदा हो रहा है in that, ठीक है. But यहाँ पे what is happening over here is when we're saying that, example से ज़्यादा clear हो जाएगा, when we're saying that you are transiting traffic, ठीक है, and not getting paid for that, transiting traffic belonging to somebody else, then you wouldn't want to do that. For example, जो customer जो sort of provider network है A, it advertises a path AW to provider B, ठीक है. So path AW का मतलब ये है कि that you can get to destinations A, you can get to destinations W, ये advertise करेगा B को, ठीक है. And उसकी वजह क्या है कि ये AW क्यों advertise करता है B को, so that B के beyond जो networks हैं, they know about its customer W, ठीक है. And if they know about its customer W, or if they know about the addresses over here, then traffic can be routed to to these destinations through provider A. And उस traffic को provider A को पैसे मिलेंगे, because all traffic that is routed to its customers, ठीक है, उसके ये जो ISP A है, it will get money for that, ठीक है. So A के benefit में है that it advertises path AW to B. Similarly, it will advertise, B will advertise path BAW, ठीक है, to X. So that X knows that if it needs to get to customer W or to destinations जो A and B के अंदर है, ठीक है, so ये it should take this path, ठीक है, because if this path is used by X, ठीक है, to get to certain destinations, तो B को पैसे मिलेंगे, it'll get revenue out of this, because when traffic appears or is populated on this link over here, ठीक है, B will get revenue for that from customer X, ठीक है. So if customer X wants to connect to customer W or to a network customer जो कि यहाँ पे है या इसके साथ connected है, तो उस सारी ट्रैफिक को के जो है ना, B provider B को X से पैसे मिलेंगे, you'll get revenue out of that for all of that traffic over here, ठीक है. Now the question is that ये जो path है BAW, ठीक है, should B advertise this path to C? BAW वाली path C को advertise करनी चाहिए इसको. And the answer is no. And the reason is that B does not get revenue for routings traffic which is CBAW, ठीक है, because W जो है वो उसका customer नहीं है. So while W is a customer of A को revenue मिलेगा for that traffic, but ये जो traffic which is destined for W, if that gets routed through CBA, ठीक है, तो उसको उसके जो है ना it won't get that money. So we would want to force C to route all traffic destined to W through A, ठीक है. So B only wants to route to and from its customers. So जो traffic X के लिए destined है, अगर वो यहाँ के through जा रही है, तो इसको फायदा है, it would want to do that. C के साथ वो directly भी connected है, तो C के interest में ये है कि if any traffic is destined to X, it directly forwards it to X rather than routing it through B, ठीक है. So it's basically these revenue agreements between these network providers as well as the customers which determine that सब paths आपने लेनी है traffic में, ठीक है? So you can think of these ISPs, or you can think of these autonomous systems as they are large networks controlled by some autonomous body, but you would want to ensure that आपको ट्रैफिक कैरी करने का नुकसान नहीं हो रहा है। तो आप अपने जो कस्टमर्स हैं उनकी ट्रैफिक, ठीक है, या उनकी तरफ ट्रैफिक कैरी कर रहे हैं, लेकिन जो आपके कस्टमर्स नहीं है, यू आर नॉट एक्टिंग एज अ ट्रांजिट, ठीक है, फॉर देम, जनरली स्पीकिंग। दैट इज द प्रिंसिपल। ओके, एनी क्वेश्चंस हियर? Any questions? So, policy in inter-AS, inter-autonomous system routing, the admin wants to control how traffic is routed, who routes through its net, and so on. Okay? And within an autonomous system, there is a single admin, so no policy decisions are needed. So at the boundaries, you would require these policy decisions. Okay, ji? You would not want to route traffic to, let's say, India. Okay? You would not want your traffic to be routed through India. Okay? India would not want its traffic to be routed through Pakistan. Okay? And so on. So these could be policy decisions, and so on. So you might have some decisions where, for example, it does make sense to peer, and it does make sense to peer and exchange traffic without charging the other, because it's beneficial for everybody. And uski example जो है वो internet exchanges की है. So for example, let's say you've got these networks over here, A, B, and C, and ये links suppose ना होते, ठीक है? A gets its traffic internationally through some outside ISP, and B also gets traffic through that same outside ISP, and C gets traffic through some other ISP outside. So let's say you had traffic going from, let's say these were 3 cities. You had Karachi, Lahore, and Islamabad. So let's say A is Lahore, C is Karachi, and B is Islamabad. The ulte side pe hai, but just for argument's sake. So if the traffic did not have any peering relationship within the country, so then traffic from Islamabad or from Karachi or from Lahore would have to go all the way to the US before it gets routed back to Pakistan. And ye hota hai for a long time, because these different network providers did not have any direct links within the country. So by having these peering relations within the country, or internet exchanges within the country, it makes a lot of sense that you route local traffic, and you might not even want to charge for that, because then usse dono providers ko fayda ho raha hai that they are saving on international bandwidth or international जो traffic जा रही है बाहर, उसके ऊपर they're saving, that rather than having their traffic routed to the US and US backbone से वो traffic route होके वापस कराची आ रही है या लाहौर आ रही है, it is directly routed through peering links that they have with other ISPs within the country. And वो जो internet exchanges हैं, they are typically run on a sort of on the basis कि जी जो local traffic है उसको appear करेंगे, and it's going to be, because it's beneficial for everybody, these peering relations are sort of maintained in internet exchanges which are local to the country, and typically managed by neutral entities such as universities. And uska fayda phir ye hai कि everyone benefits out of it, because traffic does not have to get routed internationally back to the same country, and usse jo hai na dono ISPs ko nuksan ho raha hota hai, because they are spending a lot of money on routing traffic to the US. It's inefficient, it's expensive, and does not make any sense. But that will require some trust between these ISPs and some point जहाँ पे ये peering आपस में कर सकें, ताकि आपस की जो लोकल ट्रैफिक है वो एक्सचेंज कर पाए. Okay, right, so any questions over here? So policy is between ASs, it's all about policy, that how traffic gets routed. Then within an AS, it's you have the routing is done based upon the protocols such as your link state or distance vector routing algorithms, and वो वाले सारे इस्तेमाल होते हैं वहाँ पे efficiency के लिए. Then you would want to, if you think in terms of scale, then hierarchical routing saves table size, because जब भी आप aggregation करते हैं, so that is really going to be helpful in terms of aggregating different network addresses into the same common prefix, and then that reduces the updates that you require. But still, typically ये जो routes हैं BGP के and so on, they run into tens of thousands, not उससे भी ज़्यादा, hundreds of thousands of entries के अंदर ये typically they can run. So when you have these big routers, your typically table sizes are huge. So within an AS, you can focus on performance, and between ASs, it's policy that dominates over performance. That's the key takeaway. Okay. Okay. So any questions over here? Any questions? BGP can. Okay. So we'll come back to broadcast and multicast routing. Okay. The next thing that we want to cover or start talking about is the link layer. Okay. Link layer services में primarily the first service is framing, and framing means कि जो IP packet है आपके पास उसको आप encapsulate करेंगे into a datagram or frame, adding a header and trailer. ठीक है? Then the next key thing is channel access, and that is important, especially if you have a shared medium. So if the medium जिसके ऊपर आप communicate कर रहे हैं is shared, for example, it's wireless, so all your different hosts are connected to the same wireless router, say, ठीक है? Then the question becomes that how do you access the medium? How do you access the channel? ठीक है? And उसके लिए that becomes an interesting problem, because there are issues such as who gets to talk and when. ठीक है? Then you've got some kind of addressing that's going to take place. So you need medium access control or MAC addresses, and these are used in the frame headers to identify both the source as well as the destination. And these are local, these are different from IP addresses. So different protocols have different link layer addressing techniques, okay, and which are different from IP addresses. Notice that they are only relevant for your local area. And typically, ये जो hardware addresses कहलाते हैं या MAC addresses कहलाते हैं, these addresses are sort of hardwired typically into the sort of आपके पास जो cards होते हैं उनके अंदर they're also sort of configurable, ठीक है? But what you would want them to be is if they're for example manufacturers जो हैं, they are provided a certain prefix, and then they ensure that each of the network cards that they produce have a unique hardware address. So then that combination of the manufacturer and the number of that particular card that has been produced by that manufacturer that is guaranteed to be unique in the world. And वो typically, for example, Ethernet के लिए, that's a 48-bit address which you have, and that 48-bit MAC address is unique for each Ethernet port that you have. And this address is used at the MAC layer or at the link layer to identify both a source and a destination. Okay, we have a question here. So, okay, and we have an answer as well. Okay. Okay, so you've got addressing at the link layer. If you have a point-to-point connection, then of course addressing की जरूरत नहीं है, ठीक है? But if you have a point-to-multi-point connection, or you have got multiple sort of hosts which are sharing a common medium, then of course addressing has to be done. And this is local addressing, okay? And we've seen how to do reliable delivery hop by hop, okay, in the internet, but this is reliable delivery between adjacent nodes which are connected to these, which are next to each other, which are connected through a common medium. How does one deliver a datagram, or I should say a frame, one hop away? Then you've also got issues related to the reliability, because you want reliable delivery. And if your medium is reliable, for example, fiber is a very reliable medium, okay, then of course your bit error rate is going to be very low, and then you might not need to have these extra sort of bits which are used for detecting errors in these frames. And if your frame is corrupted, then it will have to be retransmitted. So you might not want to do that if your medium is very, very reliable, such as fiber, which typically has a bit error probability of 1 bit in 100 million, 1,000 million. 10 to the power -6, -8 is the typical bit error rate probability in fiber optic links. It's much lower in wireless links. So wireless links के ऊपर you do have to worry about reliability of the frame being received correctly. Okay. So the question is that why do you have both link level as well as end-to-end reliability? Well, link level पे ये है कि if you know that a link is error prone, then you might want to retransmit or resend a frame there and then, rather than waiting for the end system to detect कि जी ये problem आई है, that frame would have to be retransmitted hop by hop through the entire internet again. So उस चीज को sort of mitigate करने के लिए you might want to have link layer reliability built in. Other things that you could do is our flow control or pacing between adjacent sending and receiving nodes, error detection and error correction. So detection का मतलब ये है कि you detect कि error हो गया है. Correction का मतलब ये है कि ना सिर्फ आप detect करते हैं, you not only identify that an error has taken place, but you also correct the error without resorting to retransmission. So if the probability of error is low, then there are techniques in coding theory which allow you to very cleverly, very जबरदस्त तरीके से, समझदार तरीके से, they allow you to correct those errors without having you to retransmit that entire bit. So they allow you to identify कि अगर error हुआ है तो कहाँ पे हुआ है, and उसको they allow you to correct that error, which is truly amazing. Then you have to worry about half duplex and full duplex transmission, which means that nodes, they can transmit and receive, but not at the same time. That's half duplex. In full duplex, they can transmit and receive at the same time. If they are to do that, then of course, they would require you to use maybe a separate channel or maybe something else. Otherwise, masla ye hai कि if you transmit and receive at the same time, so then you'll have collisions in the transmissions. So you've got to, in full duplex, you have to manage that through techniques that you'll have at the physical layer. some adapter which receives your datagram, and it's going to encapsulate that datagram into a frame by adding a header and a trailer. That frame will be received by an adapter one hop away, and the header and trailer will be stripped off, and you will then receive the datagram at the receiving node. So the link layer is typically implemented in an adapter, which is also called a network interface card. And you have different examples of these network interface cards. Pehle ye network interface cards, typically they were hardware cards. Okay, you would slot into a bus, or you would slot into a port of your end system or host of your computer. But now they're typically built into the motherboards. So you've got Ethernet cards, which are the most prevalent. Then you've got PCMCIA cards as an example. ये भी Ethernet 802.11 cards, and the different standards over here. But all of these cards, for example, your DSL modems के हैं, बाकी चीजों के cards हैं, or they are all sort of built into your routers, and so on the sending side, you're going to encapsulate the frame, encapsulate the datagram into a frame, and in the header, you're going to add these checking bits, error checking bits, as well as bits for flow control. And on the receiver side, you're going to look for errors, as well as flow control, as well as extract that information then ultimately. And the link layer is the name that we use, but if you want to be very, very sort of pedantic, then you'll say link layer and physical layer, but we lump that together, and link and physical layers को इकट्ठा ही हम sort of treat करते हैं in sort of modern communications. Right, so any questions here? Okay, link layer क्या है, क्यों है, क्या करती है? So link layer is responsible for getting your datagram one hop away. So notice network layer is worried about getting your packet hop by hop across the entire internet. Okay. Now, whereas the link layer is एक hop से दूसरे hop. So notice कि in the internet हर hop के अंदर आपके पास network layer के नीचे एक link layer होगी जो कि technology dependent है, जो कि उस frame को अगले hop तक पहुंचाएगी. ठीक है. So जो भी आपका IP packet है, it will have to be encapsulated into a link layer frame and transmitted hop by hop to the next hop, जहाँ पे वो दोबारा से headers, trailers निकाल के IP packet निकाल के IP packet की basis के ऊपर वो router decision लेगा, and router जब connect करेगा किसी अगले hop के ऊपर तो किसी link layer के through connect करेगा, which means that it's going to re-encapsulate that IP packet into a link layer frame based upon the technology जो इस्तेमाल हो रही है. अगर वो Ethernet है तो उसके हिसाब से Ethernet frame बनेगी in your first hop. अगर between routers आप कोई wireless link इस्तेमाल कर रहे हैं, fiber optic link इस्तेमाल कर रहे हैं, तो उसके मुताबिक आपके पास कोई appropriate link layer technologies जो है उनके मुताबिक frames बनाई जाएंगी. लेकिन actually hop by hop जो चीज travel करती है on your internet, on your physical sort of network, on your physical links, that is a link layer frame. Okay. So IP packets by themselves they're not transmitted. They have to be encapsulated into some link layer frame जो कि technology dependent है. So let's say you have a smartphone, you have IP packets, आप browsing कर रहे हैं, net की जो IP packets हैं, they are going to get encapsulated into a 4G, ठीक है, frame, LTE based or whatever technology that you're using, and that frame is going to go from your handset to the base station. Base station पे फिर वहां से अगले routers तक connect करने के लिए it's going to get encapsulated into the appropriate frame. It could be SDH, it could be SONET, it could be IP over any one of these link layer technologies, and इस तरह से hop by hop आपका packet आगे internet में चलता जाएगा. Okay, so any questions here? the first thing we want to talk about is error correction and error detection. So EDC, error detection and correction, the key idea is that you have a datagram which has D bits. आप कोई extra bits, error detection and correction bits add करते हैं to your datagram, and you send that across a bit error prone link. So what is received over here is not exactly the same things transmitted. If there are errors over here, आपके पास एक D prime और EDC prime चीज मिल जाएगी. Now with you know कि आपने EDC bits किस तरीके से calculate किए हैं, ठीक है? They'll be based on certain coding algorithms, and when you receive this, you're going to check and see कि अच्छा ये जो आपको चीज मिली है ये ठीक मिली है या नहीं मिली. So you'll check and see whether all the D prime bits are okay. If they are okay, then the datagram is fine and you will send that up to the network layer. अगर error detect हो जाता है, if they're not okay, then you've detected an error, and then based upon detecting an error, आप आगे मजीद decisions लेंगे. So the first simplest thing that you can do is called parity checking. And parity bits, as you know, are basically one bit that you're going to add, okay? And you could have an odd parity scheme or an even parity scheme. So if you have D data bits, in the odd parity scheme, the idea is that you will have an odd number of ones over here. And if you do that, that is the goal. You should have an odd number of ones in the D bits as well as the parity bit. Is sabko mila ke you'll have an odd number of ones. Already have an odd number of ones, the parity bit is going to be set to 0. If you have an even number of ones over here, then this parity bit को आप set करेंगे so that you have a result, you get a total of an odd number of bits over here in the D plus 1 bits. ठीक है? So it's the opposite in an even parity scheme. यहाँ पे the goal is that you have an even number of ones in the entire D plus 1. ठीक है? अगर वो already ones even है, you have two ones in this case, so ये bit set to 0 होगी. अगर ये 1 1 1 होता यहाँ पे, then that is 3. So to get an even parity scheme, you'd have to set this bit to a 1 so that you have 4, which is an even number of ones in the D plus 1 bits that you have. Single parity में आप ये बता सकते हैं कि when you receive and you count the number of ones, if you have implemented an odd parity scheme, and if the number of ones that you get is even, then you know that at least one of the bits must have flipped. So ये जो आपके पास चीज आई है ये corrupted है. You can detect an error. Similarly, using even parity schemes, you can detect an error. Now, the interesting thing is that if you put that together, okay, so you have, let's say, you have I words to send, okay. Each one of these words is of j bits, ठीक है? And ये आप क्या करते हैं कि हर row के लिए you're adding a parity bit, and then what you do is you add a column parity bit for each one of these columns. So in other words, you're implementing two-dimensional parity. अब उससे होता ये है कि if you implement two-dimensional parity and then you check to see कि आपके सारे के सारे rows ठीक हैं, and you check to see कि सारे के सारे columns ठीक हैं. And if you find that there is an error, a parity error in a particular row and column, then you would know that error has taken place at that intersection. Because agar error hota hai in whatever you transmit, let's say one bit gets flipped, that would result in both a row and a column error. Now, on the assumption that your bit error probability is low, ऐसा नहीं होगा कि multiple bits are going to get errored. Typically, when you transmit these words, probability of multiple errors is very, very low. That's the assumption. Then, by examining the parity bits row-wise and column-wise, अगर आपको एक उनकी intersection पे error मिलता है, you know कि that's where the error took place, ठीक है? And you can then correct that error. So you can correct a single bit error using two-dimensional parity bits. Okay. So single parity say you can detect errors. With 2D parity, you can not only detect errors, but you can also correct single bit errors. Okay, so that's an example of error correction and detection. Any questions here? इसमें कोई चीज समझ ना आई हो? Odd parity क्या है, even parity क्या है, and 2D parity इस्तेमाल करके. Okay, so there aren't any columns in a datagram. ठीक है, उसमें आप यही समझें कि आपके पास ये words हैं. So if I have I rows and j columns, you will insert an additional word at the end over here, and that word is going to correspond to this column parity. ठीक है? So आपके पास actually you're transmitting one long set of bits. ठीक है? You will break that up into words, and वो जो words आपके पास हैं, ठीक है? They will actually represent that column parity. Okay. So you're correct in saying, okay, आप इस तरह से भेजते नहीं है. I mean, you will send that as one long word, but suppose कि उस one long sequence के अंदर एक bit corrupt हो गया, ठीक है? अब ये जो आपने ये जो word बनाया था, that was based on column parity. At the receiving side, if you rearrange whatever bits you're receiving in a sequence into this 2D pattern, ठीक है? और आप once again उसको check करते हैं इसी तरीके से, तो अगर वो एक बिट रैंडम पे बीच में यहाँ पे कि एरर हुआ था, तो देन उसकी कॉरेस्पॉन्डिंग रो के अंदर एंड कॉरेस्पॉन्डिंग कॉलम के अंदर आपको एक पैरिटी एरर मिलेगा. यू विल स्टिल रिसीव दैट एरर. इज दैट क्लियर? सो थिंक अबाउट दिस कि चले आपने एक लंबी चीज इस तरह से भेजी, लेकिन ये जो चीज आप भेज रहे हैं, इट्स बेस्ड अपॉन दिस 2D पैटर्न फॉर एग्जांपल. सो that particular bit is going to correspond to these previous ones. This bit over here will correspond to these previous ones. And ये जो आखिर में जो word है, ठीक है, which is the column parity for the entire all the other words, वो सारे bits जो है ना, they will correspond to the column parities like this. So when one of these bits gets corrupted over here and वो नहीं corrupt होगा, there will be a discrepancy in the column parity over there. Of course, the size of the rows and columns, ये आप पहले से predetermine करेंगे कि what is the scheme that you are using. So जो भी data आपके पास है, ठीक है, you will break that up into these words, ठीक है, and ये फिर आप correspondingly you're going to insert these row parity as well as column parity. आप उसके साथ ये extra add करेंगे, and then you will transmit that. So that's predetermined. Because unless the sender and the receiver agree on a certain fixed algorithm that they're going to use both to create the CRC as well as to detect errors as well as correct errors on the receiving side, तो उस वक्त तक जो है ना, this is not going to work. ठीक है? So they don't necessarily send the size of rows and columns. They're going to agree on a technique. ठीक है, और उस टेक्निक में जब आप डेटा लेंगे, सो यू विल नो कि ओके एवरी 8 बिट 16 बिट 32 बिट वर्ड के साथ आप एडिशनल एक पैरिटी बिट लगाएंगे, ठीक है, एंड देन कॉलम पैरिटीज आप लगाएंगे. सो यू विल बी सेंडिंग दीस एक्स्ट्रा बिट्स, ठीक है, as part of your parity checking, so that उसके थ्रू you can actually do this error detection and correction. Okay, so notice this is something done at the link layer. ये जो higher layers हैं, they don't know कि ये कैसे हो रहा है, what's happening below. So, and the link layer doesn't know what the data is. It just treats that as a ones and zeros. So it says, okay, I'll take a block of 32 or 31 or 64 or 128 ones and zeros, and I'll work parity on that. ठीक है? both row wise and column wise. Typically it's not going to be that big, yani ye number 8 or 16 hi hoga, especially if you're doing this, because the whole idea of doing this is on some lossy medium. Agar medium bahut reliable hai, then of course doing this and adding these extra bits is overhead, it's redundant, because the probability of bit error rate is very low anyway. So that's going to be, यानी वो उसी लिहाज से आप जब डिजाइन करेंगे इस एल्गोरिथम, सॉरी टेक्निक को, तो you're going to do that based upon that. Right, so any questions here? Okay, so we'll stop over here, and inshallah you'll have a, we've done 7 quizzes so far, 7 mini sort of quizzes. The thought was to have maybe 2 more, maybe one this Sunday and one next Sunday, and so that you have 9 in all, and then we'll drop 2, okay? And that should sort of give you sort of some more flexibility, as well as you'll be sort of done with this. So any questions? So this time around, we'll simply be covering from the distance vector onwards. So distance vector, RIP, OSPF, BGP, and ये जो parity checking है, link layer की basics and parity check. Okay, so any questions here? Okay, so Assalamu alaikum.